Welcome to Unity 6 course, Part 8. In this chapter, I will explain about how to move an object and work with the transform component. How to rotate, how to move, how to scale an object in different ways. So let's get started. You can access to all chapters and the other parts from the playlist here, and also the link is in the description. Here in the code, we need to remove these lines, which I explained about them in the previous chapter. Now I want to explain about a new class to access to the transform component of each object. Here, as I said in the previous part, we need to define everything as private because for the safety of the data, in some scenarios I will make some variables and objects public. Private, the class I want to introduce is transform, and I'll name it tra. Alright, this transform we can drag and drop and assign a transform component from a game object to this field, but I need to make it serialized field to make it accessible in the inspector. Alright, when we select the game object, as you can see, we have a transform, and we can drag and drop the camera. As you can see, it filled out with the transform component related to the camera. We can drag and drop the game object itself, audio source, or any game object in the scene, no matter. And we can modify the transform component of each object we want. For example, we can change the position, fields X, Y, and Z, rotation, and scale. If you want to move, rotate, and scale and modify the transform component at all of current game object you've attached simple code to, you can access to an object provided from MonoBehavior class called transform with lowercase t. It's not a data type, actually it's an object, just like game object with lowercase g, which I explained in the previous part. Now we can get access to all the features provided by the transform class, no matter you call the tra or transform. Both of them have same capabilities, same properties and methods. Alright, I will work with the transform later, but now I need to work with the tra, and for this field I need to drag and drop the cube because cube has a 3D view, 3D virtualization, and I can move it easily. When I move it, I can see the changes easily. Right, first let's start with the position and moving the cube. If we want to access the position property, we need to call the position, and it will give us this three fields X, Y, and Z. But how? How does it give us three values? I will upload every chapter of the course every week, so make sure to subscribe to the channel and turn on the notification to know about the new chapters and new tutorials. Actually, the type of the position is vector 3. Vector 3 is a type that receives three values X, Y, Z. When we get access to the position, we can write a dot, and here we can access to three fractions X, Y, and Z. Now we can print. Let's print one of them. Alright, save, and here we need to run the game. Right, let's see. It'll print the X position of the cube. Here, minus 2.04. And here, let's see the cube. As you can see, the X is correct. Is similar to the output. Alright, how to change the position? Actually, to change the position, we need to create another variable serialized field, private vector tree of type of vector tree, because position needs a vector tree. And here pose. Here we can call tra and position equal to pose. It is easy. Actually, it will put this position vector tree to this position. Save. And here we need to fill out the fields related to the vector tree here in the game object. As you can see, we have 3 values just like the transform. Here I will make it 3, 1, and 0. Alright, let's see. As you can see, it has been changed. Here, cube is in the new position. That's good. Now we know about moving the object, and we have another method to move the object. Translate method. Translate method receives a vector tree input, and it has 6 variations. Actually, we have 6 translate methods. One of them receives a vector tree. The second is vector tree and a space type. And the third variation is the transform, and it will move the object based on another object, and so on. Here we will use the simplest one, and we put the position. Let's see. Alright, now play the game and see the result. Alright, what happened here? Why this cube is placed here with these values? These are my values, but cube placed here. Actually, in Unity and all game objects, we have 2 methods to get the values, the transformation values. The local transformations, the world transformations. So, what are the differences? When we drag and drop the cube on the game object, for example, now this is the parent of the cube. And here, if I select the cube, as you can see, we have different values. The previous values were these, and after that, after reparenting the cube, we can see these values. They're different because these values are relative to the parent, the game object, and since the game object doesn't have any parent, it's under the world. Actually, the transformation values based on the world transformation, and this is the local transformation. Actually, we can change the world transformation of the cube as well, but the priority in this case is local transformation. Because of that, we have different values. Here in the translate method, actually we can, for the second parameter, we can send a type of space. Space is an enum, and I will talk about the enum later. Actually, if I write space and dot, we can set it to world or self or local. When we set it to world, it will move the object based on the world position. If we set it to self, it will change the position of the cube based on the local position. So currently you know about the local and world positions and transformations. Now let's talk about the translate. What is the difference between the translate and changing the position directly? Actually, translate will add the numbers position the x, y, and z in the position in this variable to the current position. For example, if the cube was here, it will add the values and cube goes here. And if you add again, it will go here. It will add the values to the current values. But with the position, you have more management on the moving object. Actually, you are replacing a new value to the current value with tra.position equals to pose. We are replacing actually, but here it's different. Here, let's see, it's -3. Here, this is 3. It will add the -3, -3.3 to the 3. Let's play, and as you can see, the -0.3 remains. And actually the add operation happened, and here this is the final result. And the y is 3 plus 1, it would be the 4.7. And it will work in the local position. If you want to move it based on the world position, you need to use the second parameter in the translate method. Alright, in summary, you will replace the position in this method, and the second method an add operation will be happened, and the pose will be added to the current position based on the local transformation, not world. And here let's write it in the update, and it will add this pose every frame to the current pose. Here let's see, but we need to decrease the values defined in the pose here because it's too high, which it will add frame by frame. It's good. Instead of y, because it goes up, let's copy and paste to z, and 0 for y is better. Right, let's see. As you can see, cube is moving, and it's adding these values frame by frame to the current value. Here, as you can see, the x, y, and z is changing. Alright, we can write negative values, not just positive numbers. Right, now let's talk about another property provided by the transform. It's local position. Actually, if you want to access the local position relative to the parent, you can get the local position and change its value. If you want to change the world position, you need to call the position, and we have the local position in the opposite side. Alright, now let's work on the rotation. If you want to change the rotation of the object, you need to set a new value to the rotation, and actually the rotation receives a quaternion, not vector tree. Quaternion has some extra capabilities for the rotation because the rotation process is kinda more complicated than moving and changing the position. And quaternion has 4 values: x, y, z, and w. W actually a helper axis that is very helpful for some works such as gimbal angle. You can read about it. It's actually related to mathematics, and I don't want to talk about it in this video. And you need to give it a quaternion. Here we need to change this to quaternion. Rot equal to rot. It's kind of similar to the position. And I don't want to talk about the replacement. Here, as you can see, we have 3 values, not w. As I said, w is a helper, and it's better to not modify it yourself. Actually, it's recommended, and it will not give it to you in the inspector, but you can change it here. As you can see, we have x, y, z, and w. You can change the w in the code, not in the inspector. Here, the rotation of the cube is 0, 0, 0. Let's change it to 45, 90, and 20. Alright, as you can see, the rotation, the exact rotation, is the values we've entered in the game object here. But in some scenarios, if we go beyond the 180, for example 190 or 200, we will see an artifact. As you can see, we have the negative 170, what happened? Here, the W involved to the process and actually will not support some specific values, and it will change it based on some calculations related to the rotation in mathematics, and you will not receive the exact value you have entered. And you need to change the rotation in different ways, and I will introduce those in the future in the next chapters. They are related to the advanced transformation stuffs, and this video is not good for covering them. Just like the possession, we have the local rotation, which we can change the local rotation of the cube based on the parent relative to the parent. And here we have a method called rotate, and it will receive a vector tree. The question is it possible to rotate an object using the vector tree, not quaternion? Yes, it will change the vector tree to quaternion automatically, and you don't need to involve to the complicated stuffs, and it does look like the translate. It will add a number to the current number, to the current axis. For example, here we pass the root, but we need to change it to vector tree. And here we can also give it an angle to prevent from the issue we have faced here, that we have entered 190, but it changed it to negative 170. We can work with the angle. I will talk about it later. And here we have the space and so on. Actually, we have another variation of the rotate method. Also, we have it and the translate as well, which we don't need to send a vector tree to the method. We can send the x, y, and z separately without creating a vector tree. But it's not ideal when you work with the transformations in Unity. Alright, let's test. Let's change this to a small number. Alright, let's play and see the result. As you can see, it has been added the one value for each axis to the rotation. Let's move this code to the update using the Alt key and directional keys on the keyboard and see the result. Alright, as you can see, the cube is rotating and it's very good. And it will handle the rotation, as you can see, between the positive and negative values, and it's related to the calculations and mathematics, and it will handle it automatically. Right, rotation is done. The next is scaling. Scaling is easy. We need to call the local scale. We don't have scale, just scale. Local scale, and you can give it a vector tree. Just it. Let's test. We have these values for the scale. Let's change it to 2, 1, and 3. Let's see. Alright, as you can see, this is the cube with these values and this shape. Alright, the scaling process is easy. For the last aspect, I need to say something. If you want to give a vector tree a quaternion to local scale, rotation, position, or local position, and so on, you can make a new vector tree variable in the runtime, actually in the wake or update. Here we can do it instead of using this variable, predefined variable. You can write a new keyword just like the previous chapters. Actually, when we make a new object based on the class or a struct, we need to use the new keyword and call vector tree. And here vector tree receives 3 values, 3 variations of the vector tree of the constructor of vector tree have been exist. The first one is the empty vector tree. It will fill out the x, y, and z with 0. The second variation is sending the X, Y, and Z will be 0. Third variation, you can fill out the X, Y, and Z. Here we can send 3, 1, and 0. And here we can test it, and we don't need this variable anymore. Here let's test, and as you can see, this is the result: 3, 1, and 0, based on the values we've entered in the code. Be careful when you use new keyword and creating a new object, because if you do it in a critical and complicated method like update, which it will run every frame, it can affect on the memory performance, because when you use the new keyword, it will allocate a space on the memory, and actually if you do it every frame, it's correct. When the method ends, it will remove the space. Let's see. It will remove the space allocated for this vector tree in the memory will be removed and free. But at the next iteration, it will allocate a new usage, and it will affect on the performance. And you may face with some lags in the gameplay, but actually not with a simple line like this. If you write many lines like this with new keyword, you may face with some issues. These are the basics related to the transform, and you already know about how to move, rotate, and scale the objects in the scene. In the next chapter, I will explain about inputs and how to get the keyboard and mouse inputs from the user, move, rotate, and scale an object using the input keys.